Hey everyone, I'm Sudhanshu. So today I'll be talking on something interesting project I'm working on. It's called Brahmos. It's a React implementation without virtual DOM. We'll see how it works. But yeah, uh, do people have heard about the name Brahmos? So it's a supersonic cruise missile built in collaboration of India and Russia. And recently, it was on a trending list on Twitter, and some of my friends were they used to make fun of me that your Brahmos is on trending. So yeah, someday I assume one day this will also get on trending in Twitter or anywhere. Uh, but yeah, the idea of the Brahmos, the whole project got inspired by lit HTML and hyper HTML. I'll come into what similarity on that. But the main idea behind Brahmos is to divide the application into static and dynamic parts, and on updates only compare the dynamic part. Uh, but before coming more into that, let me introduce myself. So I'm from Bangalore, India. I work at HackerRank as front-end architect. I have authored Brahmos and other couple of OSS projects, which are widely used. And I also have a deep interest on understanding the internals of the library and tech I use. So I also organize a meetup called the Internals, where we discuss the mostly the internal stuff, how something works, what's the idea behind. It's more of a discussion type of meetup where we mostly brainstorm on how something might be working. And you can see my open source projects on GitHub, and you can definitely follow me on Twitter as well. One more thing that I love React. React is great because it has got a declarative API, and it it has a well-proven patterns, whether it's a JSX, the virtual DOM thing, the context API hooks, and there are new things also coming up, right? I'll not say it's well-proven yet, the concurrent mode, but it seems promising. And yeah, I'm looking forward to concurrent mode as well. Uh, Plus, React is widely adapted library, and that is because it provides a great DX because it has a lot of tooling and community around it. So you'll find everything out of the box. You don't have to write a lot of component by yourself. You do have to write your product components, but you do get a lot of things from the community. But React can be improved further. It is good, but it can be improved further. So let's see if take example of a component. So consider this something which we are rendering from a component, and the component has some static part and some dynamic part. In this, the green node denotes dynamic part, and the blue node denotes the static part. Now, if anything changes on the component, which basically changes one of the dynamic node, the React doesn't discriminate between static and dynamic parts. What it does, it compares all the nodes available, and it figure out what is the minimal change, and it applies that change to the actual DOM. Now, when I came across a talk by Justin on the lit HTML, he introduced a pattern where uh, on the component, you don't have to really think of the static part. And whenever there is an update, you can just compare those dynamic parts. So you can ignore the static part. So basically, you can perform an update on a function of dynamic node versus in a React, it was a function of static nodes, static plus dynamic nodes. So after seeing that, the main question was, can we implement the same pattern in React? And the first thing on my mind was, can we write a different renderer with React? But the biggest blocker was the virtual DOM. The virtual DOM, because it doesn't have any hint of what is a static part, what is a dynamic part. It's really hard to do this static and dynamic classification there. Uh, Inferno is a library where which try to solve this by having some hints on your VDOM that this is a static or a dynamic, and it was like trying to do the similar thing, but it was working on a virtual DOM. The second thing which came on my mind was, can we write a React API wrapper above lit-HTML? But the problem with that was the API of React and lit-HTML, they are not directly mappable. So you can't just create same DX of React in top of a lit-HTML. So at the end, I was with trying this out by creating a new library, and I saw it as a good opportunity to learn how React internally works. And the main idea behind trying this was that try to have the same DX of React. So people coming from a React doesn't have to learn new thing, and even they don't have to change a lot on their code base. It should be as trivial as changing aliases, similar to how Preact is, right? So it should be as simple as that. But with a better engine, I'll not say better because React has a different, the virtual DOM allows it to support multiple platform. That's why people can write something on React and it works on a mobile, it works on a virtual reality, it works everywhere. So I'll not call it as better, but yeah, with a different engine, which probably will perform better in at least browsers. So let's see how React rendering work. So we can understand how Brahmos is trying to solve that. Now in React, you write something on a JSX, you write a component where you have the HTML part on it, which is basically a JSX. Now the JSX is transpiled into create element syntax. This is till React 16. In React 17 it is changed, but the idea is with Babel plugin, your JSX is transformed into function calls, and where the first argument is element type, followed by all the props and followed by all the children's. In the latest React 17, it is transformed into a different runtime method, JSX, where the first argument is element type, and the children is already part of your props. Because in a component, you always get props.children, right? So instead of doing it in a later stage, they started doing it on a compiler stage only. Now, the function call returns data structure, which we can call as a VDOM, so this is more of an internal representation of your how the view would look like, and this representation can be converted into any native representation, whether it's a browser, a DOM. It can be converted to DOM, or it can be converted to native elements of mobile or anything. So and then this basically in virtual DOM you have multiple elements. So each of these are React elements. Here in the children we have again another React element, and these elements are mapped with fiber nodes. We have a fiber architecture on React, right? I'll not go deep on that, but yeah, the fiber holds the information about these nodes. Now, whenever there is an update, take the same example. If you are changing the name here from Sudhanshu to Sudhanshu Yadav, what would happen is that it will compare the whole VDOM structure, and it will figure out what is changed on that virtual DOM. So here just the name has changed. So it will know, okay, the name has changed. So now I want to apply that change on the actual DOM. Um, let's see how Brahmos approaches for the same problem. So as I mentioned, like with Brahmos, you get the same DX. So you write the same component in JSX with the exact same React APIs. The JSX is transformed into tagged template literals using like Brahmos has its own uh, compiler part of it. So it's Babel plugin Brahmos. And the tag template literal looks something like this. You have a template tag. You have some static part, some dynamic part, and there is information about the place of a dynamic part. I'll go into this code, what this code means. I'll go into detail. Now, the tag part is nothing but just a normal function which receive two things. One is array of strings, and the second, like followed by all the dynamic values, dynamic expressions. And from the tag function, you can return anything. You don't necessarily have to return a string. You can return anything from that. One more good thing about template tag function is that the reference of strings array would always remain same. No matter how many times you are calling this, if the literal part remains same, the array reference would remain same. So we use this fact, and what we do is like from using that reference, we store a template tag. I'll come into this, what template tag is, but we store the template tag instance, so we don't have to create it every time. Like if you have, let's say, 1,000 row items with the same content, you don't have to create template tag again 1,000 times. We can cache it, and it returns the template part of it, and it also returns the template instance, and it returns the dynamic values. Now, here you can see this is much more simplified than how the React VDOM looked, right? So we have a template instance which doesn't change. This is a static part, and the only thing which change is the dynamic values. And when there is update, you can directly target these dynamic values. You can compare them, and you can apply the changes on the actual DOM. Now, coming to like how that template tag looks like. So from that static part, Brahmos create a template, HTML template tag, which has just the static part. It strips out all the dynamic part from it. And from the code, which was there on the function call, with the code, we get the information about the dynamic, like a location. So the zero, the first part of it will tell you whether it's an attribute type or it's a node type. If it is an attribute type, um, uh, which node it belongs to. So this is basically the zeroth is the zeroth index of that element. So in this template, we have just two elements, one p tag, one span. So in a let's say in a flattened array of uh, DOM elements, what is the index of your node? And same with the it will also store the attribute index. So attribute index is basically you can have multiple dynamic part on attributes. So it has to know that what all static attributes are there. So there can be like some override. If you are having a class name on your dynamic part as well, you have to know that this class name would override what is statically given, if it is coming on that spread or anywhere. So it has to get store that information as well. Similar to like that, we store um, the parent node information. So the reference node here would be the parent node for that. So one dynamic node was between the span tag, and it would store a reference, the node uh, place of its parent tag. So which is one here. It doesn't have any previous children, so it will just have the -1. So which denotes it doesn't have any previous element. Now, With this template tag, we clone it, which can be appended on actual DOM. And while cloning, we also uh, get the reference of those DOM nodes. So based on your dynamic part metadata, now we create the actual information of the place where the dynamic part stays. So for attribute, the DOM node, which DOM node it belongs to, and it would be actual reference to the DOM object. Similarly, for node part, it will store what is the parent node, what is the previous sibling. So now if you have any change, let's say we are changing the name here, and just the name is changing, while we are comparing the dynamic part, it knows what is the place of like in actual DOM, where to update that. So it doesn't have to traverse again or do something like that. It knows the exact location where that dynamic location belongs to, and it can directly make those changes. So that's a rough idea on how Brahmos work. Now, the other question is like, does it really improve any performance? So let's see how it can improve performance for an application. So the first thing is definitely the bundle size. So Brahmos right now it's around 11 KB, and it covers most of the React APIs, and it also include the upcoming concurrent mode. This was very interesting to work on, but yeah, like it kind of covers everything which React have. But it's more focused to browser. It doesn't focus the other other platforms. So mostly browser. And if you see Preact, the Preact itself is around 3.8 KB, but if you just want to replace Preact with a React, if you want to replace React with a Preact, you probably have to use Preact Compact as well. And combined, it comes around 9 KB. But the Preact doesn't have content mode support, and they have also mentioned that they'll probably not be working on content mode as well. Now coming to React, the React and React DOM combined, it's around 42 KB, and it might grow a little bigger when content mode comes. But yeah, it's kind of a lightweight compared to React, so definitely it would improve the initial load time. Plus, it doesn't only optimize the JavaScript library bundle size. It also optimizes your application bundle thing. So whatever thing is transpiled using Brahmos, the output is smaller than React's, because the React has to convert it on a JSX call with a lot of things, right? But um, uh, all the static parts are combined as a string. So if you see the overall transpiled output for Brahmos is a little smaller than React. Also, uh, usually parsing string is much faster than parsing object. So here is an example, if you are rendering something from a server where you have a const object, you store a big JSON on that. I just represented it, but you can consider like a actual object literals are there. This would be less performant than the second pattern. Like JSON.stringify and stringifying the string would be much faster than directly writing those object literal. The reason behind that is um, the JavaScript parser has to figure out whether those brackets are block bracket or it's an object bracket. It has to figure out many things. With JSON stringify, it's much clear that it would be a JSON object. There is a source for that as well, which talk mostly on this cost of JavaScript JSON. Um, and then the other way it is trying to optimize thing is by reducing, one is by reducing the render time. And how it does is basically because you're uh, combining all the static nodes as one node. So this will reduce the total number of fiber count. total number of node count, you can say. So there will be less number of less number of nodes and fibers to loop into and to process that. So probably like um, the overall complexity gets reduced. Similarly, like on update, because it updates on function of dynamic node instead of a static plus dynamic node, it would result on a faster update. Uh, One more thing which is still it's on a discussion and brainstorm phase, but it can improve your server-side rendering by a lot. Uh, in Brahmos, JSX is already transformed on string literals, so you don't have to you don't have to create object and then convert it into a string for server side rendering. So converting like JSX to create element syntax to VDOM to string, there are a lot of many steps involved, versus in a Brahmos it's already string. So this the rendering performance could be much faster there, but still need to figure out like by what factor it is. It's still in brainstorming phase. Now let's see what's the current state of Brahmos. Is it ready? Yes, it is ready for your side projects. I would not advise it to use on any big projects because one, it is not like a yet stable. It's still in development phase. But yeah, you can definitely give it a try on your side projects. There is a Create Brahmos app as well, similar to Create React app, which can help you to easily bootstrap Brahmos application. And all the major React APIs are implemented. Hooks, context API, reps, um, everything. There is one part which is still working on, which I will mention. But yeah, and the support for concurrent mode is also there, along with the suspense for data fetch. So if you want to try out those features, if you can't try out like you can definitely try out it on React experimental version, but you can also try it out on Brahmos. Um, and it also supports the new JSX transform. It is still on testing phase, but yeah, and this is something which is done. And the overall bundle size is around 11.3, but with some of the changes, it would go around 11.5 KB. Um, Now, what's next? The first thing which we are working right now is to support third-party component of React, so that like you don't have to build those components again. Um, it it kind of support third-party component because it has the similar API with the same definition. But the children API is a little bit tricky. Why? Because in Brahmos, um, all the static part are combined as one node. So there is the children doesn't look the same on Brahmos as it look on React. Like in a React, the static and dynamic are separate. They are different nodes for everything. There are multiple static nodes, so you get the children array, but it's not similar on the Brahmos. We do have a workaround for that. Like the workaround is basically like that. So if you use React Children API, we do the HTML parsing on the client side. It's fast. It's not that slow because we do cache that parsing step as well. So first time it will try to parse. Next time, if you try to apply Children API on the same string, it will not try to parse on that. It will just try to apply your dynamic values on that. So this is still in progress, but yeah, this is one blocker, kind of a blocker to support React third-party components. The second major thing which we are planning after that support is done is to support server-side rendering. Now, React has a lot many things on client side. Like It's not just the library, it is the ecosystem around it. And ecosystem involve definitely third-party library, but it also involves your dev tooling, your testing, and everything. Now, to get on that stage, it would take a little bit time. It's still it's like it will take some time to get there, but uh, how we can benefit the React community before is by giving a better server-side render thing. So as I mentioned, with Brahmos, you can have a faster server-side rendering. Also, the Brahmos was built um, in keeping like a async rendering thing in mind. So making async rendering work in server side is much easier in Brahmos. And this is what we are targeting. So it will allow the async rendering on the server side as well. Right now, React doesn't support it. You can't use suspense on the server side rendering. There are a lot of tools around it, like loadable components and all those things, but direct support is not there. And it also forces like because that support is not there, it forces lot of these frameworks like Next.js to provide a convention based approach where say like you will have a certain file to load your API data, and you have to follow this structure file and folder structure. So during static analysis you can figure out what is the route and what all files would be used, what all API call would be used. You can statically analyze by that, analyze by having that convention. So it could remove that requirement to have that convention if we support it async rendering thing on a server. And um, the idea for that is like probably you can use Brahmos just as a server-side rendering engine on the first, and later on when everything on the client side is there, you can probably use Brahmos on the client side as well. But at least any person on the React community can do server-side rendering from Brahmos. So they get that benefit along with the React benefit as well. And then there are a lot more thing to do. Definitely, like the current client side application doesn't support server side hydration, so that support is pending. Dev tool support is required. Testing has to be figured out. The writing enzyme adapter, testing with React testing library and all. And also we were thinking on how we can optimize the React third-party component. So probably we were planning to write some code mod which can transform your React packages into Brahmos packages. We can probably do it on a post-install type of thing. But yeah, and also like a Brahmos is not very tightly coupled. So probably if we can enable tree shaking, the current problem with enabling tree shaking in Brahmos is that it has to support React third-party component. And in React, we have been importing React on our file and doing react.useState, react.component. So that is a little bit tricky. That makes it a little bit tricky to support tree shakeable on Brahmos as well. But yeah, the end goal is like to have the same DX. So switching from React to Brahmos would be very straightforward. But definitely like there are different type of application which is good for React, and there are a certain type of application which is good for Brahmos. One example I can give is like if you have a lot of dynamic parts on your application, like charts and all, probably at that time Brahmos doesn't give a lot of value. But if you have a static part on your application, which is most uh, of the time, like which is the case most of the time, where Brahmos can probably help. So I okay, I have to show one demo. I plan to show it before, but yeah, missed it. So um, this is Brahmos. This is completely running on Brahmos, and I just want to show you. It looks exactly like a reactor. You have a render. You create the component in the same way. Um, you have the same hooks, use state, and everything is same. You create class components and everything similar. You have error, like all those APIs are there. So the keyed list support is there, which like this demo demonstrate all those APIs, which is from the React. The context API is there. All the hooks are there. Similarly, like I want to showcase this, that even content mode is working. So um, you can do data fetching inside the component itself. If you look into the code, um, this is similar to what React example has, right? You have state. You can also create the transition. Like if you want to show the loading state until all the data is resolved, you can show the loading state. And once the skeleton state is there, you show that, and you resolve the other part. Similarly, like if you want to show loading until everything is resolved, you can do that as well. So it does support all the suspense and everything. Even like we have a suspense uh, reveal orders on React, right? So it does support that as well, that things are revealed on from top to bottom. So here it's a random, like the API are mocked to randomly give result on 0 to 3 second. So the result is coming on a random duration. But yeah, like the fun fact would never come before uh, the timeline, like the profile data. So all of those are there. Even the suspense reveal train, like if two asynchronous things are taking a very fraction amount of difference, like around 50 millisecond type of thing, it tries to combine those async rendering together, so that you don't get um, too much of page relayouts on your page. Like um, it does support whatever the React concurrent mode tries to accomplish, and even the CPU demo which was there. So with the content mode, like my page is responsive, and there is a delay on every of this item of 1.5 millisecond. So if I show that. Not this, but yeah, like in every of this element, there is 1.5 millisecond manual CPU delay. And you can see, like in a normal, it doesn't stop, but if you disable the concurrent rendering, now if it goes beyond the input is so it has its own implementation of a fiber architecture, which is a little bit different than the React, but it does have the time slicing and content rendering. So that's all. Uh, Thank you, and I am open for any question. We have time, right? Yes, we have some time.